Welcome everybody. Today we're going to be talking about a new word. New word. Alright? Let's see if you guys can guess the word based on some other words that you guys already know. Alright? New word, but you guys are going to guess what the word is based on other words that you know. What do you call it? For example, here is a little container, alright, that has some water in it. How can you tell it's water? It goes up and down like that, see? There's a little container that has water in it. And I have a little weigh boat. You guys know what a weigh boat is, right? With some powder.
What is a weigh boat?
It's the things you were weighing out the salt in. Remember the sodium carbonate? A little plastic container. If I put this into here and stir it up, that powder will what in the water?
Dissolve.
Dissolve.
Disappear.
Dissolve. Disappear is another idea. Do you think it really disappears and goes away?
No.
It's still in there.
And
And you know how you can tell is because if you have water and you taste it, it tastes a certain way. But then you put salt in there. The salt goes in and what do we say?
Salt
Dissolves. It dissolves. But then the water begins to taste salty, right? The water tastes salty. So we know the salt doesn't disappear, right, Frankie? The salt doesn't disappear, it what? Dissolves. It's there, but it does, we can't see it then, right? Isn't that interesting? Have you guys ever noticed that? It does remove itself from our eyes. We can't see it, but it's there, you can still taste it. Now, some things you put into water and it doesn't dissolve, like dirt. Have you ever put dirt into water?
Yeah.
Well, I put water on dirt.
Okay. It'll sometimes wash dirt away, water, but
If
the
you have
dirt
enough dirt, then
doesn't disappear like
it just
salt
turns into
does.
mud.
It just turns into mud. And so the little particulates of dirt are spread out amongst the water, but they don't disappear or dissolve. Okay? So, there is a branch off of the chemistry tree. Have you guys ever seen the chemistry tree?
Nope.
Here it is. See? All these little branches that come off here. Alright, yes, there's so many different branches on the chemistry tree. Okay. And there's roots in the chemistry tree as well. There's a branch on the chemistry tree that's completely dedicated to this idea that some things will dissolve and disappear from view, and some things do not dissolve in solutions. It's that important.
Dad, some things are working.
Some things are not working. So, what we need to do now then is we need to introduce to you the
Tim,
chemist's
I was thinking the same
word.
thing.
The chemist's word for dissolve. Or when something dissolves in water, we say that that thing is soluble. Soluble. Can you say soluble?
Soluble.
All right. When something will dissolve, we say it's soluble in, and now if you're talking about water, you'd say water. Because this doesn't need to be water. It could be something like,
Milk.
you guys know any other liquids?
Milk.
Milk.
Or Julie.
Milk is really just water with something else dissolved in it. Did you know that?
Yeah. Just like lemonade.
Milk is like lemonade. But so lemonade is an example of water with something else in it. That stuff is an example of water with something in it.
Lemonade is basically
Orange.
Uh-huh. What's that?
lemon juice is basically lemonade is basically lemon juice and sugar.
That's right.
With sugar dissolved in it.
That's right.
And water.
So
And water.
the thing that is the most in a mixture, we call the solvent. The solvent. Can you say solvent?
So
So if I'm drinking lemonade, what's the solvent?
Usually.
Always. What's the solvent in lemonade? Water. Water. Right? Because that means water is the thing that's what? The most, that there's the most of. Does that make sense? There's definitely always the most of water, right, in lemonade? Because you put some lemon juice in, but lemon juice is mostly water. You put lots of sugar in, but that's all sugar, but it's not going to make up nearly the percentage of water as you have to have water. Milk is mostly
No, it's chemistry, Tom.
water. 7-Up. What's the solvent in 7-Up? Water. How about Diet Dr. Pepper Light?
Water.
Water. All right. Is there anything that we drink that is not water, as it does not have water as its solvent?
Probably not.
Probably not is the correct answer. There's nothing we drink that isn't just water with other stuff dissolved in it. Poison is water with poison dissolved in it.
But we don't drink it or we'll die.
We don't want to drink it, right?
Since he specifically said stuff that we drink, we can't use strong acids because you don't drink.
Even strong acids like hydrochloric acid or sulfuric acid, all these, H2C3HO2 is actually a liquid at room temperature, so you can get 95% of it, or really high concentrations of it. So it can be a liquid, but you can't drink that. Right? But even if you were to drink strong acid like hydrochloric acid, it's mostly water.
So you would still survive.
Acids are solutions of that chemical mixed with water. Anyway, the point is, these mixtures, we call them solutions. So I want you to begin to remember these words. Solution, solvent, and soluble. Soluble means what? It's able to dissolve. That's right. Solution is what? What's solution?
The product of
The mixture, right? The mixture of something into a, what is this thing? Solvent. The solvent is the thing that's in the mixture in the highest amount, right? Which is often water. Can you guys think of a different solvent now that you might not drink, but that you might be familiar with?
vinegar.
Vinegar is water with a little bit of the acid.
So you can drink it, you won't die because there's water.
Salad dressing is water, right? Anything else? How about, here's something you might drink and not die, but I wouldn't recommend it.
Juice.
Juice is water with stuff mixed in it.
Lime juice.
What about cooking oil? Is there any water in cooking oil?
Yeah.
Mm-mm. No water in cooking oil. It's its own thing. It's its own thing.
Because it can't be mixed.
Like butter, if you put it in the microwave, it becomes a liquid, right? That's what cooking oil is. It's not the same chemical, but it's the same type of chemical.
Wait, Dad, what if you just got a lemon
Mhm.
and just squeezed all this stuff out? Would
That's
there be
water.
in
That
it?
would be
That's
lemon
all.
juice.
It's like 90% water, tiny little bits of other stuff in it.
Acid.
So,
Tim, you water the plant and then the water goes into it.
oil. Oil is an example of a solvent that's out there. So, some things will dissolve in oil, some things won't. What's another solvent?
Pizza.
That's
Paint.
okay. Paint. What's the solvent in paint? Has anybody ever worked with paints, like oil paints that get really messy
I want
and you need to clean them up?
Yes.
Oil paints is probably oil.
Okay, oil paints, they call them oil paints because they have a high content of oil in the paint. And actually you don't use oil, you can use oil, you could use oil, but in the end, after you're done with the oil, it's all greasy and gross. Has anybody, Tim, we painted your Pinewood Derby car with those paints, remember? And then there was one clear colorless paint, do you remember that one? Anybody remember doing that? Ever, there's a clear colorless paint. It's it's not necessarily a glaze. It's not a colorless paint. Sorry, it's actually kind of like fingernail polish remover. Has anybody ever used fingernail polish remover?
No.
That stuff's a liquid. That is not water, right? It has usually, or typically we think of it as acetone. So that's an example of a chemical that's not water. So here we have, let's say this is water, okay, H2O. Here's another container right here. I'm going to say this has oil in it, okay? Here's another container right here. I'm going to say it has fingernail polish remover, FPR, okay?
FPR. I think I know what it is. Alcohol.
if this dissolves in water, does it mean it's also going to be able to dissolve in oil and fingernail polish remover?
Yes.
No, it will not dissolve in the oil.
It's hard to say. It's hard to say. You have to know exactly what it is. Some chemicals can dissolve well in oil and fingernail polish remover, but not in water. Some chemicals dissolve well in water, but not in these two. And some chemicals will only dissolve in oil.
Usually says.
All right? Some paints are like that as well. I'll tell you a story sometime, not today though.
Tommy's eating a cookie. Tommy's eating a cookie.
Come sit down, Tommy. So, this is the branch on the chemistry tree about solubility. Solubility. So we're introducing the term solution, solvent. Now, we haven't given this a name. We haven't given that a name. The thing that dissolves in the solvent, it has a name too.
Powder.
Powder, we can call it, that's what we've been calling it. Here's the fancy word for it. S-O-L-U-T-E. The solute. The solute. So, what is this part called? Solvent. This thing is the solute. Mixed together, they're called the solution. Soluble is whether or not this will dissolve in the solute. Whether or not the solvent. Whether or not the solute will dissolve in the solvent. So I say, is this soluble in water? Is this soluble in oil? Is this soluble in fingernail polish remover or acetone? Okay? Does that make sense? So this is important because sometimes when you perform a chemical reaction, like here's an interesting chemical reaction that we're going to perform an experiment on in the future. Here's a chemical called CuSO4, copper sulfate. And I can show you that this is soluble in water on the board here by writing AQ, which means aqueous or dissolved in water. All right? This is called copper sulfate. And AQ means what? Which means it's dissolved in water. Okay? If I combine that with Na2CO3, aqueous, which means what? Dissolved in water. Are you guys familiar with this chemical?
Yes.
That's the chemical that we're working with, right? If I combine these two together, both of them in water, so here's one container here, right? Here's the copper sulfate. Here's the other container here. This is what? What is this one going to be? Copper sulfate is a blue solution. This one is a colorless solution, right? You guys have seen solutions. Hey, that one is as well. We're not having that one in this reaction here, but we have copper sulfate in this. If I combine them together in one big container, you might think it's a light blue solution, but what happens is you get copper and the carbonate and the sodium and the sulfate.
So just copper.
They will mix.
Like this. Copper carbonate. What does that little thing right there say? S. What do you think the S means? It means solid. Solid, which means it's not what? It's not soluble in water. It's not soluble in water. And this one over here, what did I have for that one? Can you read that? That's AQ. That's supposed to be AQ.
Aquatic.
Aqueous. Aqueous. Meaning it what? Dissolves in water. Now,
But
the
did you
blue-
hear what
the-
Tim just said? That's
what's
how
that?
you can remember what that word is. He said aquatic.
Aquatic, yeah, something.
You ever
that's
heard
aquatic.
of
Good. Aqua.
aqua?
Agua. That's how you say it in
Agua.
Spanish, right? Agua. Agua. Quiero agua.
So that's how you can remember AQ
Alright.
is water.
Copper sulfate. What color did I tell you it was? Blue. And this product over here ends up being a powder. And if you let it settle, it'll be on the bottom here. It'll just be on the bottom.
So two liquids become
A solid.
And this is a blue powder on the bottom. And this is colorless.
Cool, I would like to try that.
Sounds like my blue
We're going to
sand
try
I
it.
have.
We'll try it tomorrow, or no, Monday.
My blue sand I have as well.
Kind of like that, yeah. What? Because tomorrow's Saturday. We don't meet on Saturday.
Dad, what color is the powder?
Right? Tomorrow's Saturday?
Yeah.
Well, it's blue. It's very fine blue color. And the solution up here is colorless.
What's the because C operate what's it called?
Sulfate.
Sulfate.
Take 15 seconds to
Is that a powder?
This is dissolved in water.
Is it a powder?
Yeah. You could, yeah.
Is that blue?
Uh-huh. All right. So this process of taking two aqueous solutions, mixing them together, and making a solid in an aqueous solution is called a precipitation reaction. Precipitation reaction. Precipitation means changing phase. Here it's aqueous to solid. Precipitation, when they talk about rain, means goes from gas to liquid, right? Because the gaseous clouds liquefy and then fall down. The end. See you guys on Monday, okay?
No, Monday's 4th of July.
Oh, we're not doing